This video is about rhombuses, rectangles, and squares.
So let's get our definitions out of the way all on one slide. A rhombus is a special type of parallelogram that has 4 congruent sides. A rectangle is a special type of parallelogram that has 4 right angles. Now, a rhombus doesn't necessarily have to have right angles, and a rectangle doesn't necessarily have to have 4 sides that are equal. So if you were to put those two things together and have a parallelogram with both 4 congruent sides and 4 right angles, that would be called a square. We often say square when we really mean rectangle, because when we think of 4 90-degree angles, for some reason a square pops into our head first. But a square is just a type of rectangle. It's really rectangles that have 4 90-degree angles. And a square is a type of rectangle because it meets that requirement. A square is also considered a type of rhombus because it meets the requirement of having 4 congruent sides. So a rhombus is talking about sides, a rectangle is talking about angles, and a square is both of those things put together. Let's explore some of the properties of the diagonals of rhombuses and rectangles. A diagonal, as you know, connects a vertex to a non-adjacent vertex. So let's say you start from this vertex of the rhombus and connect it to the non-adjacent vertex that's all the way across the figure. And then let's create a second diagonal that goes from this vertex to the other non-adjacent vertex. One property that you see about these, of course, is that they've been bisected. That's true of any parallelogram. We learned that in a previous lesson. The diagonals of a parallelogram bisect each other so that this is congruent to this and this is congruent to this. Now, of course, the blue line is longer than the red line, so the diagonals are not necessarily equal in length to each other, but each one of them has been cut in half. A rhombus has another special characteristic, which is that their diagonals actually form 90-degree angles where they intersect. So these angles right here in the center are all 90-degree angles, but only because this was a rhombus. So that's not true of every parallelogram. It's only true when all 4 sides are the same length. In the rectangle, which is down below, I made it a dramatic rectangle so that you could really see this. Dramatic because it's much longer than it is wide. If you draw the diagonals of a rectangle, it goes from vertex to opposite vertex and vertex to opposite vertex. You see that they most definitely do not form 90-degree angles in the middle. It's not a rhombus, right? So it doesn't have that property where the diagonals cross at 90-degree angles. It still has the property that they bisect each other. And moreover, in a rectangle, the diagonals actually are the same length as each other. They're going the same distance. So the red line, the full red line, is the same exact length as the full blue line, which means each little half is actually the same length. So I could even say, this is the same length as this, is the same length as this, is the same length as this. I could give them all a single dash to show that all 4 are going to be congruent. So in a rhombus, and let's just write these down a little bit more mathematically. In a rhombus, the diagonals are perpendicular. That's the math word for forming 90-degree angles. And the diagonals bisect the corner angles. Oh, I forgot to mention this on the previous slide. If you were to go back a slide and look at where we drew that sketch, these angles have also been cut in half. I did not mention that. These angles have been cut in half at each of the corners by the diagonals that were drawn, whereas in a rectangle that is definitely not the case. That's one of the reasons why I made this such a dramatic rectangle. This is a tiny little sliver, whereas this is a fairly large angle, so the angles are not bisected in the corners by the diagonals. So back to the properties of a rhombus. Diagonals are perpendicular to each other. That's shown on the first picture here. And the diagonals bisect the corner angles. That's shown on the second picture here, or the vertex angles. Corner is sort of a, everyday phrase. Vertex angle would probably be the better geometry phrase. So we can apply some of these properties. Let's find the measure of each numbered angle in the rhombus. So we only know this is a rhombus because it says so right in the question. So I know that all 4 sides are the same length. That's what makes it a rhombus. One of the properties I know about a rhombus is that the diagonals intersect at 90-degree angles. So that means that the measure of angle 1 must be 90 degrees. Diagonals are perpendicular to each other. Because of alternate interior angles, I know that these 2 lines are parallel, right? Because it's a parallelogram. And this could be considered a transversal. So because of that, I know this 58-degree angle must be the same as angle 2. Those are called alternate interior angles. So the measure of angle 2 is also 58 degrees. I know that because the diagonals actually bisect each of the vertex angles in a rhombus, that 3 must be the same as 2. So the measure of angle 3 must also be 58 degrees. And then I can use angles 1, 3, and 4 together. This is just one way of getting angle 4. But I can use angles 1, 3, and 4 adding up to 180 because they make a triangle. So 90 because that's angle 1, and 58 because that's angle 2. Angle 3, plus the measure of angle 4 has to equal 180. So then I'm taking 180, subtracting 90, and subtracting 58. So I get 32 degrees for angle 4 on this figure. So the property that we learned about a rectangle is that the diagonals are congruent to each other. So AC, the whole diagonal, is congruent to the angle DB, the diagonal DB. Let's apply that property in rectangle RSBF. We know that SF is 2x plus 15, so that's this whole length. We know that RB is 5x minus 12, that's this whole thing. And it's asking us to find the length of the diagonal. Well, because it says that it's a rectangle, we know that the diagonals are congruent to each other. So 2x plus 15 equals 5x minus 12. Solve for x. And then it's asking us for the actual length of the diagonal, so we better plug our answer for x back in. 18 plus 15. That's the length of SF, and when I plug it into RB, I should get the same thing. Good way of checking that you've done your work right. That's 45 minus 12, also 33. To put those two together, as we talked about on the first slide, a square is both a rectangle and a rhombus. So any property that applies to a rhombus will apply to a square, and any property that applies to a rectangle will apply to a square. So in a square, all of the special properties we just learned are true. The diagonals are perpendicular to each other, the diagonals bisect the vertex angles, and the diagonals are congruent to each other. So if you have a square, and this is not perfect because I'm just sketching this by hand, but if you have a square, you're going to know it's a square because it's labeled with this special information, 4 90-degree angles and 4 congruent sides. Then the diagonals are the same length as each other. That's because it's a rectangle. The diagonals are perpendicular to each other. That's because it's a rhombus. And the diagonals bisect each vertex angle. And that's also because it's a rhombus. And moreover, because it's square, we knew that they were 90-degree angles to begin with. We know that each one of the angles that's created at the vertices are 45 degrees because they're all 90-degree angles that have been cut in half. So you may be asked to apply some of these properties to a square where they are all in effect. And that is all.